My name is Zeeshan Qureshi. I'm a lead research engineer here at the AMRC. AMRC stands for Advanced Manufacturing Research Centre. We're basically carrying out research into manufacturing of aerospace and automotive and renewable energy parts. I work in the Composite Centre and I'm part of the design analysis and the composite automation team. And I'm making use of the Hexagon composite inspection system to perform some of the quality assurance checks on the composite parts once we've manufactured them. So we're primarily working with a lot of the aerospace and automotive as well as the renewable sectors. We are here to solve some of their in-process inspection problems by making use of some of the state-of-the-art inspection technologies that are available on the market out there. As a part of our market survey, we came across absolute arm from our partners Hexagon. We also realized Hexagon Apodius have also developed a composite inspection system specifically for measuring fiber orientations, which we believe that could be a potential candidate for solving some of the problems. It is very important for us to have an idea of the different types of defects that are present within the part and the magnitude of those defects. The current inspection process is manual, which basically means at the end of placement of each particular composite ply, the operator would go up to the part and visually inspect the composite part using magnifying glass and record it manually. Typically, it would take about 60 to 70% of the total machine time spent on visually inspecting the part, and whilst the machine is only up and running 20-30% of the time. So it's a huge cost to our partners. Hence, we are investigating some of the potential automated in-process inspection system that would help cut down that manual inspection in order for our partners to achieve high productivity. The thing that stood up from the Hexagon Apodius system was the software, which had a highly developed, highly robust algorithm for detecting fiber orientations, which was very useful for us because knowing how accurate or what the fiber orientations are of your part, it gives us very valuable information to compare against our design parts. We're primarily using the system after the pre-forming process. So once we've manufactured the part, we will scan it, and following that, we would then go on and take images of the surface that we've just scanned. And using some of the advanced algorithms that are built into the software, we're able to calculate fiber orientations, and that can give us an indication of some of the defects that are present in the part. So using this information, we can take on board and try and correct some of the manufacturing process which is causing the defects, and we would try and minimize those defects through better programming first. After that, we would go and perform an appropriate repair procedure onto the part, whether it means removing the particular layers or a section and relaying them until the part is within tolerance. So one of the advantages of having this system is that the sensor can be integrated with other composite layout machines. So we can basically take the system and mount it onto our other systems that we have within the AMRC. So once we've done that, we can go ahead and start performing in-process or online inspection to reduce the overall inspection time that our partners are facing.